All right, these are the quiz corrections for pre-calc quiz number 9, 4.1, 4.2, not using Sohcahtoa. State the trig ratio. I gave you a right triangle with sides 9 and 41 and was missing the third side. The students found the third side by using the Pythagorean theorem. Across the right angle is your C value, which is 41, and then your two legs are 9 and the unknown, which they called A. 9 squared is 81, 41 squared is 1681. Subtract, you get 1600. Take the square root, A equals 40. And then cosine of theta. Theta means the angle is your starting point. So the starting point would be here, and this would be cosine, which would be the adjacent over the hypotenuse. So cosine of theta is 40 over 41 is correct. Tangent of alpha, which means you have to go up here, and then tangent is the opposite over the adjacent. So that would be opposite from this starting angle, 40 over adjacent, which is 9, correct. Again, I reminded you guys to find numbers for that one. And then secant is the reciprocal the student has. They found cosine of alpha. So that would be cosine, which is the adjacent over the hypotenuse, 9 over 41, which they had. And then secant is the reciprocal, so you just go ahead and flip that one. All right, question number 7 says, the diagram below shows a right triangle UPC. So here is UPC, and then it says which ratio represents the sine of angle P. So if you go to P, the student labeled it opposite from angle P. You have the hypotenuse, and then the other side is the adjacent sine. They knew was opposite of the hypotenuse, so they got 8 over 17. D is your correct answer. All right, question number 8. From a hot air balloon, the angle between a radio antenna straight below and the base of the library downtown is 57 degrees, as shown below. If the distance between the radio antenna and the library is 1.3 miles, how many miles high is the balloon? So the angle they've given you is from the base of the antenna to the library is 57 degrees. So this is my starting point, and I'm going to label it. I go, I have the opposite. This is interesting. Opposite and the adjacent, and that is the hypotenuse. So the student chose tangent of 57 equals the opposite 1.3 over the adjacent. So they mix that up right there. Let's see, this one has a tangent 57 opposite of the adjacent. They cross multiplied x times tangent 57, 1.3 times 1. And then your only options here, though, if you take a look at our options, you're trying to solve for x. So they divided by tangent 57, and then they got x equals 1.3 tangent 57. And you realize all these are a calculator-ready equation. They got C, and C is the correct answer. All right, question number 9. Multiple choice. What is negative 240 in radians? Student wrote the awesome proportions. They know that our angle is negative 240 here. They multiplied here 2 pi times negative 240. And then this is the same thing as equals to radians times 360 divided by 360. They broke the factors to 6 and 60. 6 goes into 240 40 times. And then, what do they do? They're 2 and maybe 60 cancel and got 4 times 60, so 60s cancel, which they didn't show. And then you're left with 4 pi over 3, or negative 4 pi over 3, which would have been choice D. Question 10, multiple choice, convert the angle in degrees to radians, express the answer as a multiple of pi. Awesome proportion, 36 over 360 reduces to 1/10. Cross multiply, you get 2 pi equals radians times 10, divided by 10. You get radians equals 2 pi over 10, which reduces to 1 pi over 5. A is your correct answer. Multiple choice, when do you use the inverse button on your calculator? That is to find an angle measure. M is the correct answer. What is the value of secant of 70 degrees to the nearest thousandth? This secant is not on your calculator, so the student got secant of theta equals 1 over cosine of theta, which is a reciprocal identity. Theta is 70, so they put in your calculator cosine of 70 and 1 divided by cosine of 70, and you'll get 2.924. It's good. All right, which equation shows a correct trigonometric ratio for angle A in the right triangle below? From angle A, these are all A, opposite of the hypotenuse should have been 8 over 17, so that's wrong. Tangent of A should have been 8 over 15, wrong. Tangent of A, opposite over the adjacent, that's 8 over 15, not 8 over 5. That one's still wrong. And then cosine, adjacent over the hypotenuse, student labeled their triangle, looks good, 15 over 17, B is the correct answer. 14, which equation is a reciprocal identity? Secant of theta equals 1 over cosine, that's correct. Question number 15, solve for x, round to the nearest tenth. From the given angle, you label the sides opposite, hypotenuse, and adjacent. Student recognize you're using tangent. Tangent of 18 over tangent of x, that would have been nice, tangent of x equals 18 over 4. Switch them. You have a calculator-ready equation, and they got 77.47. They probably missed a point, or got to 3.75. Remember, to the nearest tenth means to this number, because this the second number is 5 or higher. You're going to round up, so you would have gotten 77.5. Now, I didn't mark off the problem for degrees because x here has a symbol, so if you put in x in there, that would have been degrees. Question number 16, solve for x, round to the nearest tenth. Give an angle, label the sides opposite, hypotenuse adjacent. The student recognized you only have things for opposite and hypotenuse, so sine of 28 degrees equals x over 50. Okay, let's take a look at this. And then what they did is they switched them, and they put the inverse. Remember, you only take the inverse to solve for an angle. X is on the outside, so you're solving for a side length. If it was for an angle, that would have been the inside, so that one's incorrect. Yeah, here the student has the correct equation, cross multiply. So you cross multiply to find side lengths. Calculated equation is correct, but they got 13.5, which is incorrect. I would have probably given 3.75. Here's the correct answer. Looks nice. This is how I awarded partial credit. 2 points if you knew that you were doing sine of 28 degrees. 3 points if you got an equation, and partial credits for less, but 3.75 for a calculator-ready equation, but then maybe your answer was wrong. Find the values of x and y, write your answers in simplest radical form. The student recognized that this is a 30, and then that one has to be a 60 because this is 90. Because all of them add up to 180, they wrote their equation x radical 3, 2x. Now, I like what the student did is they drew these arrows. If you think about what the arrows are, so they split up their equations, 30, 60, 90, and then x is unknown, y is an unknown, but look here, they pointed this one to 90 degrees because this is a known information. So you would actually start here. And they wrote 2x, and I think they were trying to figure out, well, 2 times x must equal 12 radical 3, and then they knew that it would have to be a 6 radical 3, because this is the same and this is different. So that would give you the 12 radical 3, so therefore they knew that x was equal to 6 radical 3. Put the x back into your equation here, and then you're multiplying just the radicals. That goes 9, radical 9, which is 3, and 6 times 3 is 18, so x is equal to 18. Again, x is equal to 6 radical 3, and then, well, that's for this part there, so y is equal to 6 radical 3. Good job. All right, this student, let's see. They used trig ratios, Sohcahtoa, which is totally fine. I'm probably going to put a question like this on your non-calculator to use your special right triangles. So this student used trig ratios, which if I allow you to use calculator, then you can solve it that way. And I gave the student full credit, but I definitely want you to use that on the special right triangles non-calculator side. Here's my work. You know, you could have also drawn the equilateral triangle to recognize that all the sides are 12 radical 3, 12 radical 3, and this is 12 radical 3, so half of 12 radical 3 is 2. I'm sorry, half of 12 radical 3 is 6 radical 3. That would have given you that one, and then you can have also done Pythagorean theorem, right? This squared plus this squared equals that squared to get x. If you got one of those problems correct, I gave you 3 points. A 39-foot ladder is leaning against a building. The foot of the ladder is 22 feet from the building. Find the angle that the ladder makes with the building round to the nearest tenth. So student drew a building and then 39-foot ladder. They knew that find the angle that the ladder makes, so here's the ladder, to the building. So x is placed correctly, and then my partial credit for that problem was, if your picture was correct, but and you incorrectly placed x, I gave you guys 2 points. Let's look at some more work. There's the ladder, and then they're finding this angle, so that would be the opposite over the hypotenuse, sine of the trig function of an angle, which is unknown, 22 over 39. They're showing me the arrows, that's great. Calculate rate equation, this looks awesome. Full credit, 34.3 degrees is correct. This student has everything labeled. Calculate rate equation, something happened, didn't get the right answer, but I'll probably give him 3.75. Okay, this one is showing the picture incorrect, and that would have given 1 point. Nothing. Although they labeled that one correctly, they put the angle down here. In word problems, you may need to read the problem several times. The building is not 39 feet, and it says, that's why I circled it, a ladder is leaning. So this is the one that's leaning. Also, you know, just life experience would be helpful for you guys in thinking about the word problems. So backside was 16, and then front side was, I don't know, 26, and then 2, I think this grows out of 40. Good luck.
Math.
Say it again.
Our math.